Hello? Great, fabulous. Okay. So I'm going to be reading off of notes. I'm going to be slightly less dynamic than the other speakers. You'll forgive me, but it will make sure that I come in under 15 minutes. So we'll have that going for us. I'm also going to hand this out. This is the, if anybody wants it, that's the money slide of me trying to do an algorithm as a humanities scholar. I am the oddball here, and I really appreciate you guys giving me your time. This is me doing big data in Shakespeare. So my name's John Mulligan. I have a PhD in English literature, and I teach, write, and facilitate research at the intersection of the arts and the sciences. Over the last 2 years, I taught myself the ropes of supercomputing and cloud computing with help from my Rice colleagues. And today I'm going to introduce you to the data set I trained myself on. So this is human learning, haha, and how I built and optimized a particular algorithm appropriate to a specific use case for it. The problem. Since I started working in research 2 years ago, computing research, I found myself in the middle of a fascinating debate, or perhaps, more accurately, an impasse. My computationalist colleagues did not quite understand why literary scholars weren't using the supercomputers for text mining, and my literary colleagues did not understand why I was using supercomputers at all. A recent academic firestorm put a fine point on this impasse in which both sides seemed actually to really only speak past one another. Nancy Da, in the prestigious journal Critical Inquiry, argued that computational methods are underpowered for the noisy signal they're trying to process. You see she only used the laptop here. We are at a data science conference, so this audience will know that the problem with computers in the humanities is not the shortage of computing power. But let me try to explain where she's coming from here, why she's so annoyed with the computational textual analysis as a method. Her opponents in several venues argued that she's measuring their success using the wrong metrics, but they sort of proved her point. Andrew Piper, in the Journal of Cultural Analytics, wrote a blog post in which he used the reproducibility crisis in the sciences as an analogy. The title of his piece was, "Do we know what we are doing?" His explicit answer was, "Not yet," and his implicit answer was sort of astonishing. It read like, "Can anyone ever really know what they're doing, man?" So let me be a bit more charitable than that. Piper is not wrong that our ways of knowing have changed in the age of big data. Recent developments in text analysis have moved from strict keyword counting to fuzzier, more probabilistic methods that mimic scholarly reading practices. My favorite branch of big data text analysis focuses on the fuzzy problem of referentiality instead of just keyword matching. Joseph Dexter's quantitative criticism of literary relationships in the Proceedings of the National Academy of Sciences in 2017 is a great one. And Matteo Romanello's got a lot of good work here, but I like his citational study of intertextuality in classical works. These papers use sophisticated methods to detect intertextual quotations in scholarly citations, which allows computers to aggregate networks of influence. So generally, this method catalogs patterns in ways that would take humans years to do. These patterns are immediately legible and useful to scholars in the field, because indeed, what these methods detect is the internal structuring entanglements of a scholarly discipline with its object of study. That's a complex sentence. Don't worry, I'll keep coming back to it. So these analysts are measuring the infrastructure of a field, basically. My big lesson here is for data analysts to respect domain expertise, if only because there's really good data there. And I'm sort of reiterating a point that was made this morning. The data set. Today, I will describe how I transformed a citational data set into a recommendation system. This transformation is important because it demonstrates that in scholarly metadata alone, there is enough rich structured data to mimic scholarly behaviors. The fact that my simple algorithm works suggests that Shakespeare scholars do actually know what they are doing. And that underscores the importance of data analysts listening to domain experts more generally. So here's my data set. The Folger Shakespeare Library has perhaps the most meticulously coded digital textual editions in existence on the left. They have coded every single word in the Shakespearean corpus. It's kind of mind-blowing. And JSTOR, in the center, has digitized, OCR'd, and meticulously cataloged millions of textual documents, though they are most famous for their archive of scholarly articles. In 2014, JSTOR undertook a project to determine what of their articles had quoted Shakespeare. They have a great interface on the right, but they also had an API, which allowed me to steal all their data. So what JSTOR performed was a giant fuzzy search across two corpuses. And because we are not matching keywords but quoted passages, these matches have a rather high degree of confidence. And we can assume that there's something meaningful about each match because it was the result of deliberate action taken by an expert user, a scholar. So to reiterate, if we have lots of accurate data on highly deliberate user behavior relating to structured textual corpora, then it is very likely that we have an opportunity to perform large-scale operations on the data productive of literarily meaningful outputs. The experiment I ran was a pretty simple one. I wanted to transform the citational network provided by JSTOR, which has 623,000 edges of passages to, lines to articles, into a co-citational network, which, as it turns out, has 29 million matches of lines to lines through the articles. What we have here is a network of play lines connected to other play lines through scholarly citational practices. Such correlations of user behavior data are the bedrock of recommendation engines, as people here probably know. And this data set is this data set in particular is constituted by the small but deliberate actions of expert readers. In the domain of text analysis, what this means is that instead of counting keywords in the hopes that keyword matches are meaningful, we can count associations that scholars have already told us are meaningful. So my algorithm there favors heavy co-citation in individual articles, but of course you could do it differently. So what we end up with is a responsive user interface that carries a user from text to text across the Shakespearean dramatic corpus as though wandering through a Shakespeare professor's daydreams, is how I like to think about it. So where other people count keywords and hope that they're meaningful, I'm counting citations, and sometimes keyword matches fall out of them, right? So whenever I have a keyword match, it's always meaningful because someone said it's meaningful, right? So that's pretty cool. What you're going to see here is dropif, drops, right? That's happening without ever looking at the content. Now, if we do another one, we click through here and make that the seed passage. Then the matches that get made here, this one's more thematic, but it's pretty cool. So it's Henry V lamenting the deposition of Richard II, which is the thing that made him king in the first place. There's a lot of like word type matches, crown, gown, wood, staff, but mostly it's a historical and thematic match. So you won't get that from keyword mining. Okay, so building my 29 million line database took work. First, I ran an optimized and HPC job to create the co-citational network, and then because the interface was really laggy with such a large database, I ran an HTC job that pre-calculated the results. So the HPC job I made has one master checkpoint process, which assigns batches of play lines to a scalable number of worker processes. These many worker processes then took up what documents cite these lines and what other lines are also cited in these documents. Two recording processes then take those co-citations and record them. So why two processes? Because looking up line A, we will find it co-cited with line B, and then later, when we're looking up line B, we'll find it co-cited with line A. So it's a natural artifact where you have two parallel data sets, and instead of saving myself work, I decided to allow for that doubling of work because it's a perfect data validation method, right? All right. But these workers obviously have to wait on each other to have their results written, and so we get a massive bottleneck problem. Different play lines, as you might expect, are more heavily cited than others. Hamlet is a lot more popular than the Merry Wives of Windsor, and those lines are highly clustered because people tend to cite passages, right? And so all of these workers running through that data ended up backing each other up. So what I did was I randomized the selection so that the master was assigning random lines, one from Hamlet, one from Merry Wives of Windsor, and when you get bottlenecks, it's just sort of incidental, right? And it clears really quickly. So you have two bands here. The workers are at the top, and the master and recorders are at the bottom, right? That's running much faster, and it exited cleanly. So here, the next optimization problem that I had was the general one of scalability. So how many worker processes could I run in parallel? This is a graph of tests I ran on the isomorphic problem of making an article recommender instead of a passage recommender. And what I found was that there are actually two optimization paths here. And one is more processors and smaller work assignments, and the other is larger work assignments and fewer processors. All right. It turns out that the processors, not the workload batch, are the primary sticking point. I zeroed out the jobs that fail, so you see that sharp drop-off when I pushed it too far. Okie dokie. So it actually maxes out. You want large batch sizes and not too many processors. I'll jump ahead, but those are the stats up top if you guys want to ask me. All right. So however, after running my web interface with a 29 million SQLite database on the back end, it was rather slow. So the game was hardly playable. And so I chose to run a second process as an HTC job in which I had the game play itself for us. This took 16,000 CPU hours with 150 CPUs for each job. And I finished it each time in a single run. And I made 20 lookup databases. So here's a little speed test. This is the old version of the game. Brutal, right? OK. So what I had was I had the game play itself in a giant HTC job. Oh, it's just painful, isn't it? This is great television. OK. And here's the faster version, which is actually using a more complicated visual interface. So it's got a little bit of lag there that the other one didn't have. But it's still over 5 times faster because I've pre-calculated everything. All right. Those lookup databases have 114,000 entries apiece. OK, so that's a speed up of about 5 times, although on the remote VM, for some reason I have not been able to pin down yet, I had the speed increase of 10 times, and I'm still working out how to do a proper apples-to-apples comparison. So, all right, future work. I would love to see metadata analysis, the sort that I've done, integrated with actual keyword analysis so that you could have these sorts of like keyword matches that people are doing, enriched by the obvious value of the scholarly work that's been done in the past. Because sometimes it's just odd how people mine keywords and try to act as though no one's ever read these texts before, when people have spent hundreds of years doing this and giving them all of this valuable data on what's meaningful and how it's connected. There's no reason why we shouldn't be looking at that stuff. I'd like to test different use cases with experts to see if they can't layer even more data in there. And I'd like to experiment with other data sets. This is more or less generalizable, even if my code is really clunky and works better and is very hand-tuned to the Shakespeare data set specifically. But JSTOR does have other data sets that have the exact same structure, so you could use it there as well as on essentially any other citational data set that has a primary source with secondary scholarship linked to it. All right, that's everything. Thank you. Questions?
How far away are we from being able to do this kind of analysis on a substantial portion of literature written in the English language? Obviously, Shakespeare was one of the first things people did this kind of stuff with. But if someone wants to compare something in pop culture, the Game of Thrones or Tolkien, to something, the Canterbury Tales, is that something that's going to happen in 50 years, or what do you think?
No, I think it's going to happen a lot faster than that. And people sort of have this problem backwards in the humanities, where they think, oh, our literature is really complex, and so that makes it super hard to analyze. That's actually what makes it really easy to analyze from this perspective, because it makes matching so much easier. So if you're dealing with, something as structured as what I'm dealing with here, which is quotations, you're just going to be able to find those matches right off the bat without a bunch of hand-tuned inputs from people cleaning up OCR and stuff, because you just have so much to work with there. That's my perspective on that.
Speaking of OCR and classic text, do you ever use, spatial analysis for those texts?
I don't, but the Humanities Research Center has a whole GIS wing, I suppose you could call it, where they're building these really complex maps that have the possibility of layering in a lot of interesting metadata. There's a really good article by Elizabeth Maddock Dillon called A Sea of Texts. I think it might still be online, but it's in the scholarly edition you actually get the maps that go with it. And she took Olada Equiano's interesting narratives, so there's a lot of possibility of doing travel narratives and tagging them with where the segment of the text that you're talking about is located to sort of trace people's paths. And what she does is she uses that as a backdrop to do sort of theme analysis as she goes along. And it's all hand-coded, but that allows her analysis to be that much richer because it's bespoke, in my opinion. Yeah, so that's a cool essay to look at.